Okay, so today I want to go over complex redox equations. So the first step, you want to just write your equation out as it's shown. The second step, you want to find the oxidation numbers. So if it's alone, you just write what's in front of it or not. And then if it's in a compound, oxygen and hydrogen is either a +1 or a -2. And to figure out Mn and Bi, you have to write an algebraic expression to whatever the sign is. So set that equal to that. So once you find oxidation numbers, you want to figure out your reduction and oxidation equation. And those oxidation numbers will help you find the reduction oxidation equation. So for the reduction, so we have BiO3 minus makes Bi plus 2. So the second step, you want to balance out any other elements, but since Bi is already balanced, you want to balance out your your oxygen. So to get that, you get BiO3 minus, so there's 3 oxygen on this side, makes Bi plus 2 plus 3 H2O. So that balances out the oxygen, because you have 3 H2Os with 3 oxygen. Your next step, after you balance out your oxygens, you want to balance out your hydrogens. So since up here, we have 3 H2Os, 3 times 2, that makes 6 hydrogens because you have a coefficient of 3 in front. So then you get 6H plus BiO3 minus makes Bi plus 2 plus 3 H2O. After that, you want to figure out your oxidation numbers to figure out how many electrons you'll need to balance. So we have a +6 here, a -1, which makes a +5, and we get a +2 and a 0, which makes +2. So in order to get +5 to +2, we have to subtract 3, since +2 is a lower charge. So we have 3E minus plus 6H plus BO3 minus makes Bi plus 2 plus 3H2O. And that's our reduction equation. Now our oxidation equation, you start with the same thing, right? Mn plus 2 makes MnO4 minus. This is your simple chemical equation. Then you want to balance out any other elements. But since Mn are both balanced, they have 1, we don't have to worry about that. So then we move on to our oxygens. So we have 4 oxygen here, so we need 4 oxygen on this side to balance it out. So we get 4H2O plus Mn plus 2 makes MnO4 minus. So since we have 4 oxygens on this side, we need to balance it out, putting hydrogens on this side. So we get 4H2O minus plus Mn plus 2 makes MnO4 minus plus 8H plus. So then there's 8H pluses on this side, or 8 hydrogens, and there's 8 hydrogens on this side, so they cancel out from each other. So then we look at our charges. So we have a 0 charge here, and we got a +2 here. We got a -1 here, and a +8 here. So that makes a +2 and a +7. And we always want to get to the lower charge. So we have to add 5 electrons, as shown here, to get to a +2. So then we got a 4H2O plus an Mn plus 2 makes an MnO4 minus plus 8H plus 5E minus. So that's all the steps coming down to reduction and oxidation. So then our last step, we want to balance the electrons. So as we notice in our reduction equation, we have 3E minus. In our oxidation equation, we have 5E minus. So you want to find your least common multiple. So our least common multiple of 3 and 5 is 15. So the reduction equation you want to multiply by 5, and the oxidation equation you want to multiply by 3. So for the reduction equation, after you do that, you get 15E minus plus 30H plus 5BiO3 minus makes 5Bi plus 2 plus 15H plus 15H2O. Then for our oxidation, you get 12H2O plus 3 Mn plus 2 makes 3MnO4 minus plus 24H plus 15E minus. In our final step, to get the final equation, you just want to cancel anything out. So you get 15E minus, 15E minus, that cancels out. Then you want to cancel your H2Os. So you got 15 H2O and 12 H2O, which makes 3 H2O. And then we have our H pluses. 3H plus minus 24H plus. And for our final equation, we should have 6H plus 5BiO3 minus plus 3Mn plus 2 makes 5Bi plus 2 plus 3MnO4 minus plus 3H2O. And that goes over the complex redox equations.